Hello, good morning. So today I'm going to start properties of determinants. This is one of the important topic in class 12 math. Basically, there are standard properties and determinants is actually square matrix. Like जिसमें आपका order of rows or column will be same. So I can say it is m by m. Fine. अब यहाँ पे I will explain all the properties exactly how we deal it and how to solve the same. So first property is, suppose this is my determinant. Let's say A is the determinant. So first property I could say, if I transpose the determinant and after that whatever value I am getting, right? Let's say A transpose and the original determinant, both case when you expand it and solve it, your result will be same, right? That is the final value for the determinant if you transpose it or didn't transpose. And if you expand it and solve it, in both cases, the result will be same. So this is first property. And here I can choose a single, let's say, for example, 2, 1 and 1, 3. This is one of my determinant. And let's say this is the determinant A. And if I wish to find my mod value for the same, so simple cross multiplication will happen. That is 2 times 3, which is 6. Let me show you. 2 times 3 minus 1 times 1. So it will give you 6 minus 1, which is 5. And if I transpose the same, a to the power t, then technically my row will convert in column. That is 2, 1. And second row will also convert in column, that is 1, 3. And then if I wish to solve the same, what will be my result? Like magnitude, if I would say, then in that case, again, if you see 2, 3 are 6 minus 1 times 1, which is equals to 5. So hence verified. This is the property 1. So here I'm explaining all the properties one by one so that it should be clear, right? Okay, let's move forward with the second property. And for second property is, if any two rows or columns of the determinant interchange, like if any two rows, I'm writing keywords only, we'll write any two rows or column interchange, then what will happen? Technically, determinant sign will change. Determinant sign will change. So if I write a statement, it will be determinant sign will change. So this is my property 2. P for property 2. And again, I can give you one example. Suppose now I'm choosing another matrix. I mean my determinant of order 3 by 3. So let's say I'm saying 2 minus 3, 5, and then 6, 0, 4, 1, 5, minus 7. So if I wish to change, actually, let's say I'm changing my row, like I'm shifting my row from R1 to R3, interchanging row completely. Then if you solve the same, like first is the original one, and if I change it, let's say it will be 1, 5, minus 7. And again, second row won't be affected because I change or shift that first row to third row. That's why 604. And then third row will be 2 minus 3, 5. So if you expand it and solve it, you will get the same value with opposite sign, like what you have earlier for this one, that is 261, and then 3 minus 3, 0, 5, 5, 4, minus 7. So again, result will be same. Now I'm going to third property. Third property states that is P3. Like if all the elements of a row, all elements of a row or column are 0, then the value of determinant will be 0. That is, suppose if I write an example, let's say 0, 0, 0 I'm taking, and any number you can pick. And if you solve the same, automatically your result will be 0. So this is our third property. Now I'm going to connect with the fourth property, that is P4. If any two rows or column, any two rows or column are identical, then also your determinant will be 0. That is, if I write, let's say 1, 1, 1, 2, 3, 4, and I am writing here again 1, 1, 1. And in this case, if you solve it further, you will get a 0. So it is valid for both rows and column actually. So these are the three properties which should be clear. Okay, fine. Now we can move to next property. That is property 5. All these properties normally helps you to solve or prove whether the how to solve the determinant, accordingly the values. Like suppose I am going for property 5. Here this property is each row or column is multiplied with a scalar 1. Suppose you multiply by a scalar term. I am using, let's say, k, scalar. Each row or column actually. Each row or column. If you multiply with k, then the value of whole determinant you will get that times k. That is, if I write a number, let's say 102, one example I'm picking up, and then 18, and then 36. Now here you see a relation, if you see, and that is, this is my original determinant. And if you notice carefully here in first row, I am having a common scalar term, and that common scalar term I can say will be 6, right? That is, I can take out 6 common. So I can write here, if you see, that is 17 times 6, then 6 times 3, then 6 times 6, and rest of the stuff will be same. So what I'm trying to say in this scalar multiple concept, this is my 6. Like if you solve this determinant value, you would observe exactly that the original determinant value, whatever you are getting in first case, and whatever I will get for this one, that is 17. If you see 117, and here it will be like 3, 3, 3, and then here it will be 6, 4, 6. So for both determinant value, actually you will get the same result. And if you notice technically, whatever value you are getting, If you multiply by 6, you will get the same result. This is my fifth property. Now I'm going to connect it with the sixth one. So property 6 states that if any rows or column of a determinant, like it's up to you, you can expand the determinant in the form of addition, right? Any two column or rows you can expand, or you can express as the determinant of two individual determinants whose sum is equivalent to the first one. That is, if I write like this, A, B, C, suppose now I'm using letters so that it will be more clear. A plus 2x, then it is x, and here it is B plus 2i, and then y, and then C, sorry, let me give a space so that it will be more clear. Yeah, so C plus 2z, and then z. So if you see original determinants is this, and I can expand it in the form, that is, I can say ax, and then b by, c z, and plus I can write a 2x, x, b 2i, y, c 2z, z. And if you add, actually it's z, if you add all these things, automatically you will get this determinant. That is what I'm trying to say. If you expand this, and if you add, you will get the result, whatever you will get here. This is the sixth property, one of the important property. Now another property I'm going to connect, that is property 7. Property 7 states that if the determinants, all the elements, I mean below the diagonal or above the diagonal, are 0, right, then simply you can take the diagonal element product, and that will give you the direct answer. That is, suppose if I write A, B, C, and here it is 0, E, F, 0, 0, I. Now you see here you have 0. Actually, later on in higher class, you will study this is a special type of determinant. We call it a row echelon form. Right now, it is not in your course, but later on you will study. Here, these are 0, a special form of, you can say, determinant. And if you get like this, then simply what you will do, you simply multiply all these three elements, and you will get your result. That's it. A times E times I. You will get your answer. And it doesn't matter, either it could be 0 at the bottom, I mean in the lower triangle, or in the upper triangle. That I can write like this also. If you see, that is, I can write A, E, I, and here I can place my zeros, right? And rest of the non-zero elements here I can shift. That is, let's say it is G. This time I'm using another letter, H, K. In both cases, your answer will be same. A cross E cross I. So these are like 7 properties for determinants. And you can see fundamental properties which will help you out to solve how to expand, how to prove the determinants. And technically everywhere you need to apply the approach so that you will get the answer. You need to focus, or you need to work out with these properties only, like what things you can take common scalar terms, how you can express, add or subtract the two determinants, or like I told you, one more property, like if any rows, all elements of the rows or column are 0, then also determinant value will be 0. Hope you enjoyed the video. Thanks for watching. Bye. Take care.